Hello my dear students, it's a pleasure to meet you in our educational program of Geology and Environmental Sciences. I'd like to remind you, last time we talked about the different type of erosion and the act of the different agents as aggradation and degradation. In our today's program, we'll continue talking about the river stages. Let's start with the following. What are the stages of the rivers? Yass stage. In the stage of the Yass, the river is vigorous and erosion is rapid because of the steep gradient or slope. The gradient of river is expressed as a ratio between the difference in elevation and the distance between any 2 points on its course, expressed in meters per kilometers. Gradient usually decreases in the downstream part of the river. The river deepens its channel, which becomes V-shaped in this stage. The river gradient is usually not constant, depending on the hardness and resistance of the rocks in which it cuts its channel. It may make sharp cuts in softer bedrocks, with lakes and waterfalls being common in its course during the stage of Yass. The next stage is the maturity stage. In this stage of maturity, the stream gradient has become more gentle and erosion more slow. The ground surface is lowered toward the base level of erosion, the level below which the stream cannot erode, and will ultimately reach the lowest level, which is the sea level. During the stage of maturity, meanders commonly develop and may be cut off to form oxbow meander lakes. Old age stage of At this stage, the river has become old with very little energy to erode and is very close to the base level. The river channel takes the shape of curve instead of the original V shape. The curvature becomes gentle near the mouth, and the area has become almost a plain, and this area is known by peneplain area. Rejuvenation stage. This stage is occasionally occurred under certain environments. However, if land by any geologic process is elevated or volcanic eruption occur in an area, the river may increase its rate of erosion and cuts in the new elevated land and continues flowing in its course. The river which was in the stage of maturity or old age, where it has increases its rate of erosion to overcome such an obstacle, is said to have been rejuvenated since it had restored and increased its power to come to the stage of Yass once more. So it will start its Yass stage again to continue its path. In this case, the river deepens its channel by eroding the former alluvial floor of the valley. This results in step-like terraces. The process of rejuvenation may be repeated so as to form a group of terraces, with the younger terrace at a lower level than the older one. Now, my dear students, let's go to this question: how rivers act as an agent of deposition. It means aggradation. The ability of a river to carry and transport a load of sediment is related to its power. In flood time, the sediment load increases and becomes coarser because of the increase of the discharge of the river and present the velocity of water. Solid matter carried in the suspension or as bed load start to settle down when the discharge and velocity decrease. Usually, the decrease in discharge is seasonal depending on the flood time, but the decrease in velocity could be related to obstacles in the course of the river, or when the river opens and pours its water into a large standing body of water like the lake or the sea. Let us have a look on the deposits of the river Nile in Egypt. As an example, we have two major units that are responsible for the agricultural wealth of Egypt. We have the floodplain deposits, which extending from Aswan to Cairo, pour the river channels, and the delta deposits in the lower Egypt. Floodplain deposits, were formed nearly every year for thousands of years during the flood time, when Nile water became much more than its channel can carry or accommodate. The water with its suspended load of mud fine sand stepped over the river bank. This fine material was deposited at a rate of about 1 millimeter per year to form the alluvium of the fertile land of Upper Egypt. The delta on the other side was formed when the Nile water was discharged into the Mediterranean Sea. Previously, Nile had 7 branches reaching the sea. The most eastern branch opened in the sea near Port Said, while the most western one was near Alexandria. At present, only the Damietta and Rosetta branches still exist. The other branches were silted down and buried under the deposits of the delta. Year after year, the delta grows laterally and increases in the thickness by deposition of new layer on top of the old ones. At present, the Nile Delta extends from north of Cairo for about 160 kilometers till the Mediterranean coast and for about 150 kilometers from east to west between the branches of the Nile. The delta sediments reach about 2 kilometers in thickness as known, from oil and gas wells drilled in many localities like Abu Madi gas field. It is worthy to mention the delta deposits in contact with the seawater may be contain placer deposits with economic importance, such as gold, diamond, antimony, and limonite. In Egypt, the black sand appear in North Delta region, as well as in Rashid Coast, until Arish and the east and coast and contain monazite minerals, which is a radioactive mineral, limonite and zircon, which are used in ceramics. Now, my dear students, let's go to another agent of weathering. It is the groundwater. Groundwater is found beneath the surface, contained in spaces with bedrock and soil. Part of the rain water is falling on the ground, infiltrates in the subsurface rocks through the intergranular spaces and joins to be stored there till it is needed. The upper surface of the groundwater is known as the water table. Below the water table, voids and intergranular spaces below it, the voids are filled with water, while above the void and intergranular spaces are filled with air. The water table may be close to the ground surface, especially near streams or lakes from which water seeps, but it lies at greater depths, more than 100 meters, in desert or mountainous regions. In the Nile Valley and Delta, the water table is a few meters below the surface, where an area of land reclamation, like along the Cairo-Alexandria deserts road, the water table at a depth of 60 to 140 meters or more. The movement of groundwater is governed mainly by the porosity, the permeability of the rock containing and storing the water, which is known as aquifer. The porosity of the rock is the volume percentage of the pore spaces, while its permeability is the ability of water to pass through the rock. Sands and gravels, detrital-like sand and gravel sediments, are the best aquifers because their grains size allows them to be both porous and permeable. Clay and shale, on the other hand, are not permeable. The cemented equivalent sandstone and conglomerates have low porosity and permeability too, because cement has filled some of these spaces. The type of rock also plays an important role. For crystalline rocks, like igneous and metamorphic rocks, are not good aquifers. We don't have any spaces, because they are crystalline rocks with very little or no space or voids between their constituent minerals. However, the top part, when fractured, may contain some groundwater. Now, my dear students, how groundwater acts as an agent of degradation. Let's go to groundwater as a dissolvent agent. Groundwater, when acidic by dissolving some carbon dioxide, may completely dissolve rocks such as limestones, which made of calcium minerals, which is calcium carbonate. Percolating water may widen joints and fractures and form wide caves in limestone. On the other hand, when groundwater is alkaline, it will dissolve silicate. The dissolved most material is calcite, silica, and iron oxides. Will soon be deposited when the conditions have changed to the adverse and are not suitable for dissolve the deposition of the calcite from water. Percolating limestone so as to come out from a fracture in the ceiling of a cave as small drops. We have stalactite and stalagmites. Stalactites hanging from the ceiling wall, stalagmites projecting upward. As you see here, we have calcium carbonate deposits. We have carbonate deposition coming from the ceiling of the cave and from the ground of the cave. The one coming from the ceiling is the stalactite. The one coming from the cave ground, it is stalagmite. Now, my dear students, from the floor of the limestone cave are common examples, as we said, stalactite and stalagmites. These depositions are known as dripstone since they were deposited from water dripping from the surface to an air-filled cavity. Dripstone in the form of stalactite and stalagmites are found in a cave in the Eocene limestone at Wadi Sanur, east of Bani Suef. Calcium carbonate may also be deposited inside shell cavities within limestone. The shell cavity may be filled completely to result in a mold of the original fossil. Silica is also deposited from groundwater and is seen to replace plant fibers in solidified wood or as cement in many types of sandstone. Now, my dear students, let's go to another agent of weathering and deposition. It is the ocean and seas. Ocean and seas water is continuously moving by the action of current, wave, and tides. Movements of the seawater result in erosional and depositional action. Erosion by the sea is performed by the action of waves and generated by wind. During a storm, when wind velocity is high, waves hit the coastal zone vigorously. The impact of waves on rocks, like in cliff, for example, is more powerful when the waves are loaded with rock fragments and detritus. This will cause mechanical breaking of the rock and makes joints and fractures wider. The effect will be noticeable to a great extent when the coastal rock differ in hardness and resistance. Softer rocks are eroded more easily and at a higher rate, resulting in differential weathering. Ledges and caves may form. Also, the effect of waves on rocks is more in the direction of prevailing wind, resulting in the form of a series of heads and bays as seen in the Mediterranean coast of Egypt to the west of Alexandria. When the coast zone is made of limestone, tides also cause erosive effect through tidal currents. tides result from the pole of the moon and the sun of the ocean, which result in the movement of their water. The difference in the water level between the high and the low tides is seen in many regions. It is seen in the Red Sea coast region as flat areas that are covered with water during the high tide and becomes exposed or emerged during low tide. So it is an area beside the shore, and it seems it is formed for the high tide and low tide. And by watching the high tides time, we find that they are covered with water. We have surface currents in oceans result in the movement of surface water from warmer to colder areas. The movement is caused by variations in temperature of water, which result in changes in the density and salinity too. Cold water is heavier than warm water. Also in warm regions, evaporation is more active and causes water to be more saline and accordingly have which tend to sink, displacing less dense water below. In polar regions, surface water is frozen to ice made of pure water. Hence, the remaining seawater has become more saline and benches by the action of the detritus carriers. Now, my dear students, what about the sediments of the sea floor? The sea is the end station for the weathering products and detritus carried by rivers and other transporting agents. Recent studies have shown that topography of the seafloor has a marked relief and becomes wider with greater slope in the downstreams at the mouth. The increases in depth away from the continent is not at a constant rate, and the seafloor is not smooth. It is more or less similar to the topography of a continent, with mountain chains, hills, and volcanic cones. Also wide plains, deep basins, and very deep trenches and canyons. The mid-Atlantic ridge is an elongated mountain that rises for more than 1,000 meters above the sea bottom in the middle of the Atlantic Ocean. The shoreline, with its sandy beaches, marks the contact between the continent and the sea. Away from the continent to the sea, floor slope more or less gently to a depth of about 200 meters. This established seafloor platform extends for about 65 kilometers and is known as the continental shelf. It is followed by the continental slope, where the sea floor shows an abrupt steep slope to deep sea basins or abyssal zone. Studies shows that each of these zones has characteristic sediments which will be discussed as follows. We have 4 regions along the oceanic profile. To the continent and to the deepest part of the ocean, we have littoral zone, shallow water zone, abyssal zone, and abyssal zone. As you see, my dear students, this is the connection between the continent and the oceanic water. Beside the continent, we start having this zone, which is the littoral zone. The littoral zone includes the interval between the deposits of this zone consists of the brought to the ocean by rivers in addition to products of wave erosion on the coastline. My dear students, some deposits here are known by specific phenomena. We have a spit, which is elongated ridge of the sand or gravels that projects from the land at the mouth of a bay and ends in open water. Also, we have a barrier bar which forms in the front of a bay and may completely blocking its mouth, transforming the bay to a lake. These bars are common in the lakes of Edfu and Mariot on the Mediterranean coast of Egypt and have to be dredged yearly to restore the contact between sea and the lake waters. Explain the shallow water zone. This is the gently sloping zone of the continental shelf, extending to a depth of 2,000 meters. Sediments in this zone decreases in size with increases in depth and distance from the land. The sediments are a good example is the Nile Delta cone formed in the Mediterranean in the front of the delta and shows these variations in size and types of sediments brought by the Nile. Sea life is well developed in this zone because the water is warm and well aerated, with dissolved oxygen sufficient for life, and sunlight penetrated to a maximum depth of about 80 meters. We have another zone along the oceanic profile, which is the abyssal zone. This zone starts with the continental slope increasing from the water is quiet with no effective currents. Light doesn't penetrate and the water temperature is more or less constant. Basic sediments include the finer materials that settle to the bottom of in the absence of currents. These are represented by mud with very little fine sand and calcareous and siliceous traces of floating organisms that settle to a bottom after death, like foraminifera, siliceous radiolaria, and diatoms. Now, my dear students, we come to the end of our today's program. I hope you got benefits from our today's episode. Until we meet next time, I have my best wishes and goodbye.